Hello and welcome back to Tech Days Online 2017. For this session, I have got a really amazing expert in for us, all the way from Austria, Rainer Stropek. He's not only an MVP in more technologies than you can shake a stick at, but he's also one of our special MVPs. We call them regional directors. So he's one of the regional directors for Western Europe. So Rainer, welcome to the show. And tell us a little bit about that regional director thing.
Hi Andrew, thank you for having me on the show. I'm really love to join you here at TechDays. Yes, you see, in the MVP program, we really much focus on certain pieces of technology like Azure or Visual Studio, but the Regional Director program, it's more a broader thing. We are talking about strategies, we are discussing Microsoft strategies with the community, and on the other hand, we are the voice of the community when it comes to product strategies, long-term developments, back to Redmond. This is our role as regional directors.
Wow, so that's really interesting. And you've been playing, we just were chatting before we started, with Azure for some time now, haven't you?
Yes, we have. We started our flagship product, which is called Time Cockpit, 2 weeks after Azure went into production. So we have been using Azure for many years now, and it was a very interesting time. To be honest, I don't want to live without Azure anymore. Our entire business model is built on Azure. We built our entire product and our company in Azure, and therefore I'm very much used to working with this cloud platform.
Okay, so Time Cockpit. Obviously you're offering, how does that sort of leverage this Azure thing?
You see, Time Cockpit has been developed as a software as a service solutions from the very ground up. So we were born in the cloud. This is not a product that has been around for many years and was just adopted to Azure. We developed it from the very first day with Azure in mind. So we have a multi-tenant solution which offers this service, the software as a service from Azure, and we're using many of the services that Azure provides. So we store our data in Azure SQL database. We do Service Bus, of course. We use blob storage, table storage, websites, and many other services. Recently, we started going into the serverless space using Azure functions and things like that. So we bet the farm on Azure, and Time Cockpit has been built to run perfectly fine on this platform, and we are happy with this decision.
Yeah, fantastic. And my world, we were chatting before. I used to sort of set those servers up, and then virtualization came along, and now we have containers and we have Docker. But I kind of traditionally have that pegged as being an open source play. You know, that we have little Linux workloads running in isolation. But you actually do all this stuff on the Microsoft stack as well.
Absolutely, and this is what I would like to show you in this session, because many people see containers and Docker as a pure Linux thing. And if you are a developer, for instance, and you run your development workstation on Windows 10, for instance, you might get the impression that Docker isn't a very useful tool for you. But things have very much changed in the last few years. Docker is as important for Microsoft and Windows-oriented developers as it is for the Linux space. To be honest, I mean, the operating system is not that important anymore. You can mix and match Windows and Linux in the Azure platform and use Linux-based containers side by side with Windows-based containers. I think these two worlds are blurred now. So I think containers is a very important topic for all developers, and today I want to demo how .NET developers can really benefit from using Docker in their daily work.
Fantastic, Rainer. Right, let's do this.
Okay, very good. So let's go into my session. I have not prepared any slides because I love doing live coding. That's really what makes sessions interesting for me. But the thing with live coding is that people watching this video might try the samples on their own. So let me first, before we go into the demo, point you to this link here. It's a bit.ly link. It says TechDays Docker. It leads you to my blog. So those guys who watch this video and who want to replay the demos that I do, they can read the blog article. It's a step-by-step repetition of what I show here. So this is the material. So we don't have slides, but we have a blog post.
Well, thank you very much for putting that together for everybody. So do check that out after the show.
Absolutely, very good. Thank you. So let's stop the slides here and go immediately into the command prompt, because I want to kick the session off by talking a bit about what is so great about Docker, because maybe some people who watch this video are not that familiar with Docker and wonder why Docker is relevant for them at all, because they already have virtualization. And let me start this session with a very simple demo. I'm going to start here with Docker run a new container, and in this case I'm making it an interactive container. When I stop it, I want to get rid of it. That says --rm, and I just say, hey, give me a new Ubuntu server, for instance. And now I hit enter and I'm done.
Wow.
This is the awesome thing about Docker. It's blazingly fast. If I want to get rid of it, I just say exit and it's done. That's really interesting, because these containers, they are not simulating hardware like virtual machines do. They are really run on top of a virtualized kernel. And the environment that runs on my laptop here, it's called Docker for Windows. So essentially what we have here is we have a Linux server, as you can see it here, running in Hyper-V on my Windows 10 box. And here I am in the DOS prompt, and the DOS prompt is running the Docker CLI, the command line interface, and essentially it communicates with the Docker host running inside of my Hyper-V Linux machine. And the nice thing is that Docker for Windows is really, really simple to set up. You just download the MSI, hit enter a few times, and you are ready to go. So no need to do complex Linux setups or things like that. Everything is already set up for you. So this is really nice. And if you think of what you can do with this kind of virtualization, so with containers instead of virtual machines, it's really quite impressive. Because let's think of the following example. We can do the same again, spin up an Ubuntu machine. And in this case, I'm starting a bash shell and doing the ls command directly here inside the bash shell. And this rm at the beginning says it is a short-lived container. And let me show you what I mean with that. I run this statement, it does the ls command, and the ls command, and I can do whatever I want here, is really embedded in a container. This container is started from scratch. I get a completely new, fresh environment. I run a single statement. And in the course of this session, you will see that this statement could be building a .NET application, publishing it to Azure, running an Azure CLI command. So I'm just using a container in a very short-lived manner. So let me show you a second example, because not all containers are short-lived. Short-lived containers are fine for any kind of tools, CI, CD tools, compilers and things like that. But as a developer, sometimes I have to run things in the background. Think of a web application or an ASP.NET Web API and things like that. Let me show you what I mean. This time we are going to run a detached container, so it's going to run in the background. It's not attached to our standard in and standard out. Let's give it a name. Let's call it background here. And again, do a bash script. And this time we'll do an endless loop, for instance. We'll say while true, do a ping, echo ping, something like this. Then sleep for 1 second. And at the end, close the loop. That's it. So if I run this guy here, oh, I'm sorry, I forgot the Ubuntu here, no problem, because I have to tell the system which image I want to use. Now let's run it again. And as you can see, my console returned immediately, and I can use the ps command to check whether my container is now running in the background. And there it will do its job. It could be a web server, for instance, or something like this. And in our case, we can also take a look into the standard output of this container by saying docker logs background. And here you see all the pings, and it's running in the background and sending us these nice pings. And when we are done, we can get rid of this guy again. We can just say docker rm, like remove. We force it because it's already running, and we say background. And with that, our container is gone. Wow. So as you can see, these two demos showed you that the great thing about Docker is that it gives you a lot of agility. You can use short-lived containers and you can use long-lived containers, all running on your Windows box. And inside of these containers, we have Linux running. Well, that was just about Ubuntu. But what if you want to do other things, like a web server, for instance, or PHP, or a Java-based application, or a .NET application? The second thing that is really interesting for a developer is that Docker comes with this nice thing which is called the Docker Hub. Let me show you what I mean. By now, we have been using Ubuntu, and you can see there is a so-called image, a ready-made official image for Ubuntu, so I didn't have to set up Ubuntu if I want to use it. But what if I want to use, for instance, an application based on Node.js? And as you can see, in the Docker Hub, we also have an official image for Node. Or if you want to run a PHP application, you see there is an official image for PHP. So Docker is not just a great platform to run your own images, but you can use existing images, and Microsoft is really playing nicely in this area of creating official images. Because if we want to run .NET, for instance, we can look for the official .NET image, and we will see that Microsoft has created a bunch of ready-made images for various versions of .NET, for the Linux versions of .NET, as well as for the Windows version. Here you see, for instance, .NET image that is running Nano Server, so you could use that for Docker on Windows.
Wow.
So for me personally, the nice thing is not only running these containers, but also standing on the shoulders of giants by just using ready-made images and not having to set up the operating system, the web servers, the application servers, the databases, and so on. But these things I already get from the Docker Hub.
Yeah, so you don't need that IT pro guy so much inside your organization now. You're just relying on Microsoft in this case for its expertise in building this environment for you.
Absolutely, that's exactly the case, and we can take a look into these things by just clicking here on these Docker files. And as you can see, this is nothing magic what we see here. It's just a bunch of scripts and so-called Docker files. We'll not go into the details in this session, but those attendees who are interested in, they can Google Docker file and they can read on it in the Docker documentation. It's just a bunch of scripts that are there to create these images. And the nice thing is that these images are built like onions. So this Docker file, for instance, is built on the Debian base image, and it's just adding the so-called runtime dependencies that you need for running .NET Core, for instance. And if we take a look at the .NET Core runtime image, let's take a look at that one. This thing is again built on the runtime dependencies, and so on and so on. So these images are built on top of each other, and exactly as you mentioned, we don't need the IT guys, we don't need to wait for somebody to set up a virtual machine, which can take days or at least hours, and then we have to manually install some runtimes or web servers. We just take the ready-made images and put our stuff on top of it. And this is exactly what I want to do next in the next demo.
Fantastic. Rainer, just one question. When you did your Ubuntu machine, the reason that worked is because under the covers, you've got an Ubuntu VM running on your local environment. So in this case, if we were going to use Nano, I'd have to have a Windows Server VM sitting somewhere that I'm going to reference.
That's correct. If you want to run Windows-based containers, because it's just a kernel virtualization, you have to have a Windows kernel. So if you want to run Windows containers, you have to have either a Windows 10 with latest updates or a Windows Server 2016 machine to run your Windows containers. In my case, I'm using Docker for Windows, so I'm running, as you mentioned, a Linux inside of Hyper-V, and I'm communicating with this Linux machine. Well, by the way, let me show you something. I love that. You can run your bash shell, as you know, on Windows. Windows now comes with a bash shell, and the nice thing is that I can also communicate via the bash shell with my Linux running inside of Hyper-V, running on my Windows 10 box. I love this mixing of Windows and Linux and so on. You can really choose the platform that you want to write your scripts or CLIs in. I mean, that's really nice. I think this is why I love having a Windows 10 box as my development machine.
Right. Okay.
Okay. Are we ready to go into the next demo?
Yes, indeed. Yeah. Lead me to it.
I prepared an empty folder here. It's called backend, and the goal of the next few minutes is that together we create a brand new .NET Core application just inside of this folder. But imagine you are on a machine, on a Windows box, for instance, where you don't have .NET installed at all. So what we want to do is we want to use the ready-made containers from Microsoft and use .NET inside of this machine. So let's start by running a new container. Let's make it interactive, get rid of it when we are done. And this time we are doing something else that's quite interesting. I'm going to do a volume mapping. I'm going to map my local Windows directory into the app directory of the container. And that's really interesting because we are running here on a Windows 10 box and we are running a container inside a Hyper-V image, but we can still do folder sharing from my host machine running Windows with the Linux container. And this Linux container will run Microsoft, .NET, the SDK part. What we can additionally do, we can tell Docker that our current working directory should be exactly that app directory, which points to my backend directory on my Windows 10 machine. And at the end, I'm telling the system that I want to have an interactive bash shell. So if we work with Docker for a while, you get used to this CLI. It's really a very nice CLI. And well, over time, you know all these commands by heart, and you can just enter these commands quite quickly. Let's run this guy. The important thing here is that if I create now a file inside of this app folder, I'm really creating it in my backend folder on my Windows 10 machine. And with that, I can now use the .NET CLI to set up a brand new project directly here in the Linux container, although storing the resulting files on my Windows 10 box. Let me show you how that works. What we will do, we will create first a new solution, .NET new solution. If I take a look at it, we got an SLN file. The next thing is we're going to create a new project. Let's say Docker new. We're going to create an empty web project, and we're going to do, of course, the brand new .NET Core App 1.1 framework. And .NET new web, and what the .NET Core, oh, I misspelled here something. Now, we have a CSproj file, as you can see here, and we have some C# files that do the startup for us. Last but not least, we add .NET SLN, app.sln, the project, app.csproj. We add the CSproj file to the solution. So the point here, what I'm doing is I'm really using the .NET CLI inside of my ready-made container. I didn't have to install .NET Core at all inside of the ready-made container while still creating the artifacts on my Windows 10 box. The last two statements, I've prepared them. I add some references here. As you can see, I'm doing a .NET add CS project package. I'm adding the MVC framework to my application. And what you see here is that now .NET Core is going out to NuGet via the .NET container, the Linux container, and is fetching the MVC framework from NuGet. Last but not least, to make this sample work, we need CORS just for security purposes, because we are going to call this API from a web application, and so we need another NuGet package. So even if you don't program .NET very much, the point that you should remember and that you should see here is that I didn't set up my own version of .NET. I just used the ready-made Docker image. And if I exit out of this Docker image, and if I say dir, you see now I'm back on my Windows 10 box, and all the artifacts that I created inside of my container running Linux are now stored on my Windows 10 box.
It's very, very cool.
So let's give this guy something to do. What I prepared here is, let me show you my Explorer here. Of course, I don't want you to watch me typing, so I have prepared 3 C# files, and I will copy it into my backend folder just for the sake of time. So typically, imagine now we spent hours and days to create the coolest web API ever created, and let me quickly do a code walkthrough for you so you understand what we are doing here. Of course, for this code walkthrough, I'm going to use Visual Studio Code because, again, it's open source and cross-platform. You can do exactly the same on your MacBook or your Linux machine. Let me walk you through the code. The first thing is this thing runs a Castrel server, so it runs the open source and cross-platform web server from ASP.NET. And as you can see, this web server will listen on port 80. Secondly, I script down the startup file here. It just contains the MVC framework and the course options where I allow any header, any method, and any origin. And last but not least, I created a very small service here. This service just generates some random names. It just compiles random first names that you see here in line 8 and 9 with random last names 12 and 13. This API will listen on the route API names. So this is a very simple web API written in .NET Core. It should run on any platform, and we want to run this thing now inside of Docker containers.
Gotcha. Right.
The first thing that we do is we're going to run it, or let's say we're going to build it based on the ready-made .NET image from Microsoft. I've prepared this statement, so you don't need to watch me typing, but I will walk you through this statement. It's a lot of things are there that we already know. We know that Docker run starts a new container. We know that the -v option does the mounting of the Windows 10 backend folder into the app folder. We already know that the -w here sets the working directory. We already know that we are using the ready-made image .NET SDK, and here comes the interesting part. We are now running the .NET CLI, the restore command, the build command, and the publish command, so the entire continuous integration pipeline inside of the Docker container. But the host is really hosting the storage. So the resulting artifacts, the DLLs and things like that, they will be stored on my Windows 10 box. Let me run this guy here. It is a short-lived container, so it spins up a brand new image. It does the NuGet restore. It does the building as the next step. It will just finish in a few seconds. And last but not least, it does the publish. So it creates a version of the application that I can publish on a production web server, for instance, because if you take a look here, you will see that I use the release option for .NET Published. So this is not a debug version. This is really the release version of our application. So this sample should show you how easy it is, based on the existing .NET Docker images, to create, to automate your build process and publishing process with this container. Next, of course, now that we have built the image, we want to run it. And again, I'm going to use the ready-made container. Let me show you how this is done. This time, I'm doing, again, a volume mounting, but I'm not mounting my entire backend folder, but I'm mounting the ready-made, the built application, which just contains the built DLLs, the published DLLs. So I'm not putting my source code on my production web server. I'm just putting my ready-made release DLLs on my web server. Here is a new guy, -p. This option is a so-called port mapping. It allows me to run a detached container, in this case a web server, and mount the port 80 of the container to the port 8080 on my host machine. So I can just try my web API by spinning up a web browser and launching it at localhost 8080.
Gotcha.
Last but not least, I want to point out that this time we are not using the Microsoft .NET SDK image here, but you're using the runtime image. And this runtime image is of course smaller than the SDK image. It doesn't have all the SDKs in it. It just receives the built and published application that we built with the SDK container. Let me run this guy here. It runs in the background, and therefore we can do Docker logs. We already heard about that command, and say, give me the logs of the API container, and it shows that now inside of my container, my app is running and listening on port 80. But port 80 has been mounted on the host on port 8080. So what I can do now is I can start my web browser, and hopefully I can say localhost 8080 API names, and if we are lucky, the guy will answer, and here we are. Let me zoom in a little bit, and I can run it and run it and run it, and I'll get random names, and this service is now running inside the Docker container, and I didn't have to install any prerequisites or components of .NET. I just built my application in the ready-made container and packaged it inside the runtime container.
Rainer, that was fantastic. So you use one container to compile, another one to run your web service, and you've done all that from scripts. So if there's a new version of the .NET framework or what have you, you could just execute all that again rather than going through the process of patching and all of that kind of traditional stuff that I grew up with.
Absolutely, absolutely. But in fact, we are going to go one step further in just a minute or so, because of course you don't want to run these scripts manually every day or week or whenever you have a new version. Obviously, this should be part of your automated build process. Indeed. So we have to take one little step more, and then we can go into Visual Studio Team Services, and I want to show you how you can automate all this thing inside of a Visual Studio Team Services build process. But in order to be ready for that, we have to create a small Docker file. Let me show you what I mean with that.
Yeah.
I spin up Visual Studio Code again, and I prepared this Docker file just for the sake of time. And as you can see, this Docker file just summarizes the quite complex command line that I used before. It is based on the runtime image from Microsoft. It copies my publish folder. This is the folder in which I created the artifacts with the .NET compiler. It exposes port 80. It sets the work directory, and it says whenever this container starts, please start the .NET runtime and start my application, the Castillon web server, which is embedded in this DLL, this app.dll. So this Docker file is the programming language of Docker, if you want. And now that we have this Docker file, we can use it to build a brand new image. So we don't have to remember and run this complex statement with all these settings. We just want to bake everything into our own image. So let's do that. For that, we do the following. We just say Docker build, then we give this guy a new name. We say, give it a tag. I will use my name as a prefix here. Let's call it TechDays API, for instance, and tell it where the system can find the Docker file in the current directory, and run this guy. As you can see, this is quite fast because .NET is already present. It already has this onion type image where .NET is installed and configured. I just add my own application on top of it, and within a few seconds I have my own image. Let me show you what that means. If I run Docker images, you will see that I now not only have the Microsoft.NET images installed on my machine. By the way, you get these things downloaded if they are not on your machine already. So if you say Docker run and you use an image that you don't have, you just have to wait a few seconds and it will pull down the necessary bytes from the Docker Hub. But this one, the first one up here, this is really the image that we just built. You can see it was created 21 seconds ago. And the important thing is the size here. You see, the original runtime has a size of 251 megs, and our new image has 268 megs. And Docker is smart enough to detect that 250 megs of the 268 one here, they are already part of this Microsoft.NET runtime image. So it will not use up this 250 megs again on the disk. It will just use this, I don't know, 15 megs or so that my small application with the parts of the .NET framework that are relevant for it take. So this is a very nice thing to raise your hosting density. This will save you a lot of disk space and essentially also a lot of RAM and memory, and you can put more images, more containers on the same box inside of Azure, and this will reduce your Azure bills, of course, and that's important from a DevOps perspective.
It is indeed.
So, sorry?
Yeah, this is fascinating stuff. Really is.
Okay, so let's use our image. So let's kill the old Docker container that we still have sitting here. I call it API, and this time I'm going to use our brand new image. We just say Docker run. It should be run in the background, detached mode. We want to do the port mapping. We already know the port mapping. And now comes the important part. We say we want to use the RStropEC TechDays API image. So we are not using this complex command line anymore. We are not using Microsoft's .NET image directly, but we are using our ready-made API, which we generated from the Docker file. Let's run this guy. Do the Docker logs, and we see, yeah, it's running. Let's go back to the browser, and if the demo gods are smiling, we should see, yes, generated names. We have created a brand new image and stored it locally. It gets really fascinating for me if we start to push these images, Docker push RStropEC TechDays API into the cloud. Because with Docker push, we can push our software into a so-called repository. Well, what is a repository? I'm using here the official Docker Hub. So let me go to the Docker Hub here. I'm already signed in with my user, and inside of the Docker Hub we already saw the .NET image, the Ubuntu image, the PHP image, and so on. And what we are now doing, you see it here, it's uploading the files. What we are now doing is we are adding our own application, our new container, our new image in the Docker Hub. So Andrew, if you want, and if you have Docker running on your side, you could just say Docker pull down my application and run my awesome web API, and you don't have to care about how I have implemented it at all. It doesn't matter if it's .NET, if it's, I don't know, PHP, Node.js, or Ruby on Rails or anything. Yep. You just pull down the entire container and you get my fully configured environment, and that of course saves you a lot of time because you can pull down the latest version of my API every day and refresh your data center.
So Rainer, that's really, really cool that you can share your work in a role like you as MVP, RD, that you can share your code with the community for the greater good. But there are obviously occasions when you're running your day job of running your own software business where you're going to want to limit who has access to this thing. So I suppose you can do that as well?
Of course you can. You can, on the one hand, buy a private repository from Docker. Right. So it's just like GitHub. GitHub is free if you run open source. GitHub costs a few bucks if you run it in a private repository. And the same is true for the Docker Hub. On the other hand, Azure provides ready-made templates for setting up your trusted registry inside of Azure. And of course, you can, if you want, also run the registry inside of your own organization. So you have all the possibilities. You can very much compare it with Git. You can use GitHub for open source. You can use public cloud registries like Azure or GitHub private repositories, or you can run your own repositories inside of your organizations. You have all the possibilities and you can mix and match just as you like it and as you need it.
Okay, thank you for that.
So as you can see, my Docker push has been finished, and in a few more moments we should see our brand new image running in sitting in the Docker Hub. Now it's finished, and I'll refresh my browser, and here it is. Here you see my image that I created on my machine, and I didn't care about installing .NET Core at all.
Fantastic.
Now, this process of building the Docker file and pushing it into the cloud, this is what you can now automate with Visual Studio Team Services. Before I want to show you that, I want to start another Docker container because I think this is really fascinating. Because the question is now, we want to run a continuous integration and delivery pipeline in the cloud, but in our case, maybe the Docker container, the build process, needs some things that are sitting in my local area network. So what I really want is I want to run again the Visual Studio Team Services agent as a Docker container. And it turns out that Microsoft also created a Docker image for that. As you can see, there is a Microsoft/VSTS agent Docker image. I just give it the name of my account, and I give it a so-called personal access token that I can download on the website of VSTS. And with that, I run a VSTS build agent without me having anything installed manually. I run a VSTS agent which links now up to my VSTS environment. So I run my build process, I orchestrate the build process in my Visual Studio Team Services build system, and I will show you that in a second as soon as the VSTS agent has come up. And now my VSTS agent, the build service itself, it's running on my Linux box, which runs in my Hyper-V on my Windows 10 box. And therefore, I can do all the nice things that I can do on my own machine, but still benefiting from the powerful build and deployment engine inside of VSTS. Let me show you how that looks like. I go here in my VSTS, and I've already prepared that one, and I've uploaded my backend code, the code that we created together, already in this repository. I've also created a build process here. Let me show you that build process. It consists of two very simple steps. You see, Docker is already an integral part of the VSTS build system. And in this case, I'm just saying, hey, you know what? Build the image, and I'm telling the system that it should look for the Docker file and build this Docker file. This is exactly the one line that I showed you in the console a few minutes ago. And the second command here runs a push command. So this is the Docker push that pushes the image that we created one step before, and it pushes it and it refreshes it on the Docker hub. So with that, I can now queue this build, and I will tell it to use the default queue. And this default queue is now hooked up with the VSTS agent running on my local machine. So I really have a hybrid solution of Docker running on premise with the VSTS agent and the build orchestration engine running in the cloud in VSTS. Let me queue this guy. If we are lucky, we will see the build agent running on my machine picking up the job. Okay, if I go back here, you see here on my machine with the VSTS agent, it picked up the job and is now executing the Docker command on my local machine while still communicating with the box with VSTS in the cloud and doing the entire here you see the output, doing the entire Docker build command and Docker push commands, and of course all the other commands that you have seen before, like building the .NET code into DLLs or whatever you want to do. And this is a very nice example of a hybrid solution of VSTS and my local build container. And what's really fascinating for me is that I get a VSTS agent from Microsoft, from a ready-made image, without caring at all how difficult or easy it is to set up such a VSTS agent. It's just a ready-made image, exactly the same way that I created my own image.
Rainer, that has been absolutely fantastic. You know, DevOps isn't perhaps the most exciting project we'll cover on Tech Days Online, but you've made it sound really, really interesting. And I'm going to be looking at your blog after the show and see if I can recreate some of this, although I probably won't be writing such a sophisticated API for my website as you did. I'll come up with some random names of my own, perhaps. Fascinating.
Thank you very much.
And you use this at in your regular day job? This is kind of how you actually do this continuous development yourselves.
Well, partly. Whenever we run a platform as a service, today we don't use Docker already because there is one final piece missing, and I want to show you what I mean here. What you can do in Azure is, if you want to run, for instance, your web API, you typically in Azure use an app service, right?
Yes, of course.
But the app service, as it is today, is not built on top of Azure. So if you run a web app, for instance, you get a Windows-based server that doesn't know about containers. But the nice thing is that you now have web apps on Linux, and this is in preview currently. And so we are doing some side projects, and well, not our core engine, which has to rely on RTM software, but we already play with this guy here, because in that case, you can spin up a new web app.
Right.
You just give it a name. Let's call it TechDays API, for instance. Give it a second until it comes up here. Because the important thing here is that I click on the Docker Hub or private registry, and I just select the image in the Docker Hub or my registry that I created through my VSTS project. And now the PaaS service that runs my web API in Azure will pick up this image and run my container as I created it with my Docker file as a PaaS service in the cloud. So this is where we are heading to. Sure. Once this container engine has become RTM, we will migrate some of our applications over time, probably most of them, and we will run them in a PaaS service where we don't have to care about running and maintaining our Docker infrastructure. We just use the images, we just automate the build process, we push it into our registry, and from there, Azure Web Apps will pick it up and update our web APIs and websites and web applications in the cloud. This is where we are heading to.
Rainer, that has been absolutely fantastic. Perhaps we could just remind everybody of where to go and check your code out again before we finish. And
Absolutely. Let me open the website, the slide here again. Here you see the link, the bit.ly link, TechDays Docker. It's a blog article, and it contains all the demos step by step. It even contains an additional demo that I couldn't do here because of the time. It contains an Angular front end that sits on top of my web API. So those guys who really do end-to-end web development with front end and back end, check out this blog post and try to run and try to recap what we did here in your own environment. I hope that you will be as fascinated from the combination of Docker and .NET as I am.
Rainer, I can't thank you enough for this. Absolutely gold dust. And hopefully we can get you on Tech Days online and show us the stuff you just showed us in preview when it goes live.
Thank you very much. Thank you. I enjoyed being part of the show, and I wish everybody a very nice remaining Tech Days online.
Thank you. And we'll be back after the break.